So section 2.7 is going to go over combining functions. The early part of it is just some notation, which is mainly this kind of stuff, that f plus g of 2 or x, whichever it may be, is f of 2 plus g of 2. Now, the one thing that I like about some of these problems is that they're hard to cheat on with things like photomath. Let's take a look at that one with something like this, where you've got two functions, f of x and g of x. You want to find f of 2 plus g of 2. So what you would do is you'd find these points on the graph. So the graph of f of x is this one. F of 2 is up here. So f of 2 is 2, and g of 2 is 0. So you could add those together. 2 plus 0 would be 2. So pretty simple stuff. There's going to be a problem most likely where you have to do this kind of stuff from the graph. I don't think I really need to go through all of this stuff. This would be just f of 2 minus g of 2, and then f of 2 times g of 2, etc. It's just nice, convenient notation. Where it gets a little bit more interesting is when they have you deal with an f of f minus g of x, that kind of thing. This really breaks down into f of x minus g of x, which isn't bad. You just got to be careful with the negative signs. So for the first one, that's 2 minus x squared minus x squared minus 14. Where you can easily make a mistake here is to forget to distribute the negative to both of these. So what you should end up with is 2 minus x squared minus x squared plus 14. And now when you combine like terms, you get negative 2x squared plus 16. So not too bad, but a very easy place to make a mistake is not distributing that carefully. Now, a follow-up question on something like this is, well, what's the domain? And let me give you two answers. One is kind of a broad answer that I'll talk to you about in a second. But first of all, let's get at it kind of an intuitive way. Your domain is everything except places where you're going to have problems. Those problems are going to be where a denominator is 0 or you have a negative underneath the square root. Well, I don't see any denominators here. I don't see any radicals. So in short, there's no places that are going to create any problems for us. There's nothing here that's going to create an issue and that I have to delete. So its domain would be everything, negative infinity to infinity. And of course, I like to write that as script R, but I don't think you can get away with that in WebAssign. So nice, nice. But let's look back at domain a little bit and try and understand a little bit more about domain and range. So going back to our Desmos example here, let's take a look at these two things. Now the domain in each of these is different. The domain of f is is x greater than or equal to negative 2. So it's everything to the right of negative 2. And you can see that visually it works out great. You put your cursor on the graph on Desmos, you can see, oh yeah, it hits it at negative 2 and goes to the right. So the domain is everything to the right. And how about the domain for g of x? Well, that's everything to the left of 2. Now, that's getting at it visually. You don't have to get at it just visually. Let's take a look at it graphically, or algebraically. F of x was square root of, was it 2 minus x? X plus 2. All right, my bad. X plus 2 and negative x plus 2. Square root of x plus 2 and g of x is the square root of negative x plus 2. What we're concerned about underneath these radicals is having a negative number. So we want to make sure that we've got something greater than or equal to 0. So you can just solve for that. You can take this expression and say, all right, Where's that greater than or equal to 0? Oh, that's when x is greater than or equal to -2. Likewise, over here, I want -x plus 2 to be greater than or equal to 0, or -x to be greater than or equal to -2. If you divide both sides by -1, what happens to this inequality? It switches. So I've got x is less than -2. Now, these will be defined where those domains overlap. So this one and this one, I want to see where they overlap. So let's do that. -2 to 2. On the one hand, I've got x is greater than or equal to -2. On the other hand, I've got x is less than or equal to -2. Can you see that they overlap right here? This is where they overlap, in that middle part. You can see that visually. It's wonderful to look at it visually on Desmos. If you look at it in Desmos, here's the function f of x plus g of x. Bam. Notice that it's just defined there between -2 and 2. Beautiful. That's all that it's defined for. It's where they're in common. Now, you need that idea as you're working through some of these things. Some of these things get a little tricky in that regard. Here's kind of a taste of one of them. Let me shut this graph off and let's take a look at r of x. R of x is the top half of a circle. You can see it, the circle radius 4 goes from -4 to 0. S of x is this function. If I put those two functions together, say add them together to get this total function, then it's only going to be defined where both graphs are defined. So it should be defined, say, from -3 to 4. And let's see that that's true. If I add these, bingo. Look at the green graph. It starts here at -3. It ends here at 4. Perfect. And I can shut these other graphs off and see exactly what we just saw. -3 to 4. That's the new domain. That's where they overlap. It gets a little bit more annoying if this was in the denominator, because if you're divided by x square root of x plus 3, you could no longer include -3. That's because putting in a -3 would mean you'd have a 0 here, and although you can take the square root of 0, you can't divide by 0. Notice that this graph is not defined at x equals -3. Just not. You've got a vertical asymptote there. So let's get rid of that. The domain in that case would be -3 in the numerator to 4. Or excuse me, -3 to 4 would be that's domain. The -3, most importantly, would get a parenthesis. Okay. Let's do one last one. It's kind of on the tricky side from this section of the homework. And that is, I've got these two functions here. I called them j of x and h of x. And I'm going to divide them to create a new function. Now, initially, you can look at this and say, okay, well, that's, let's see, j of x, I'm sorry, that should be a 5 here. Should be 5 over x plus 6 over x divided by x plus 6. And it's true that this does simplify. If you're dividing by a fraction, that's the same thing as multiplying by the reciprocal of the denominator. So I can multiply by x plus 6 over x. It's true that these two functions cancel each other out. Equivalently, the graph's going to look like this. But technically, in addition to x can't equal 0, x can't equal -6. Because before you cancel out, a -6 will create problems in the denominator. So we have to leave that out. So overall, we have to throw out -6 and 0, and that leaves as our domain -infinity to -6, -6 to 0, and 0 to infinity. That would be your domain of this function. If you look at it graphically, that's exactly what you'll see. So let me turn on those graphs. Actually, let's just turn on that one graph. So you can see that at x equals 0, and let me just make that a little clearer here. At x equals 0, yeah, you've got an asymptote, so the graph's not defined there. But it's hard to find that other point. But if I go really carefully on this graph, and if I hit it just right, come on, a little bit more. There, oh, did you see it flash for just a second? At -6, the graph is undefined. But you're not going to see that on Desmos or on your graphing calculator unless you got a lot of skill. All right, it's not easy to find. So let's go back and find it one more time. There, it was there for a second. Anyways, it's undefined there. Now the last problem that I want to cover is something like this. Before I do, are we okay on the domain of that last one? That one's a little bit tricky. I hope you realize that when I spend time on, extra time on something like that, yeah, that's something I want you to know. Hint, hint. H of x is really two functions kind of put together. There's an inside function, which is x plus 7. So I'll call that f of x is x plus 7. And there's kind of a big picture zoomed out function, and I'll call that g of x. And g of x is when I cube something. And the goal for these types of problems is to write h of x as some function composition of f of x and g of x. Well, the f of x is my inside function, and the outside function is g of x. So if I put these two functions together like that, do I get this? Let's find out. G of f of x really means g of x plus 7. And if I then go to the rule for g, it says, okay, the rule for g says whatever you put in my parentheses, you're going to cube that. So it would be x plus 7 cubed. And that's what we wanted. If you put it in the opposite way, it wouldn't work. If you did f of g of x would be f of x cubed, which would then be x cubed plus 7, just going to the rule for f. So this way doesn't work, but this way does. Cool. Cool. Comments or thoughts on that? All right. Let me cut things off here. If you have some questions, please reach out.